Hello guys, welcome to the second video on the integration series. If you've not watched the previous video, I would advise you do that so that the understanding of this video becomes clearer. In this video, we'll be integrating functions in the form ax plus b raised to the power n dx. So that is the main objective. By the end of the lesson, you should be able to integrate any function in this form. Now, in the previous video, we realized that if you've got x raised to the power n dx and you want to integrate this one, this is basically simple. You're going to add 1 to the exponent and divide by the new exponent, and you add a constant of integration to it. This tells the examiner that there could be a possibility of a loss of constant due to the differentiation, so we are placing it there so that it caters for any constant that was available. And also we got to know that n is not equal to -1. That's because it's going to make the denominator 0 and it's going to make it undefined. Just like the differentiation in additional mathematics, if I give you y is equal to, let's say, 3x plus 8 raised to the power 10, to differentiate this one, you actually differentiate the entire function. So in this case, dy dx is going to be equal to 10 3x plus 8 raised to the power 9. Then you multiply this one by the differential of what is inside the bracket. There's 3. So the final answer is going to be 30 3x plus 8 raised to the power 9. So we're going to use something similar in integration to get the general rule for this one. And this rule is going to work. Whatever I'm going to do or whatever I'm going to say is going to work provided the inner function is a linear function. If it's a quadratic function, there should be something outside. Like I said in the previous video, this integration is restricted to additional mathematics, so it's not really going to go in depth where we've got any other function apart from a linear function over there. So let's start with a question, and I'll use a question to explain my thinking process. So let's say we've got 5x plus 8 raised to the power 7 dx. So what we're going to do with this one would be, you integrate the entire thing, then you multiply by 1 over the integral of what is inside. So let me do it, and I'll explain to you. For you to integrate, we need to add 1 to the exponent. So adding 1 to the exponent will be 8 dividing by the new exponent. Just like with differentiation, after you differentiate the entire thing, you multiply it by multiply it by the differential of what is inside. So in this case, we're going to multiply it by 1 over the differential of what is inside. Basically, it's like me saying you have to divide it by the differential of what is inside. So multiply by 1 over the differential. In this case, the differential is 5. And the final answer is going to be 1 over 8 times 5 is 40. Then 5x plus 8 all raised to the power 8 plus a constant of integration c. So that will be how to integrate this. Let me go over this again. So you integrate the entire thing, then that is add 1 to the exponent and divide by the new exponent. Then you multiply everything by 1 over the differential of what is inside. So let's take another question and see how we're going to go about it. So y is equal to integral of let's say 7x minus 3 raised to the power 5 dx. So in this case, we can say that y is going to be equal to, you integrate the entire thing, 7x minus 3. For you to integrate, you need to add 1 to the exponent. 5 plus 1 is going to be 6. Divide by the new exponent. But now you multiply by 1 over the differential of what is inside the bracket. So the differential of what is inside the bracket is 7. So let's simplify this one. Plus c. 7 times 6 should be a 42. Then 7x minus 3 raised to the power 6 plus c. Okay, so this is very easy to deal with. So we're going to solve more examples just to cover the 10 minutes. So by the end of the video, you should be good with that. So let's do another one. Integral of 1 over 4x minus 3 raised to the power 2 dx. So you can pause the video and try this one out. Okay, so with this one, what I would advise you to do is to try to write this as in a straight line. So there is going to be 4x minus 3 raised to the power negative 2 dx using laws of indices. So with this, it's also going to be very straightforward, the same ideology. So we're going to add 1 to the exponent. So we go 4x minus 3, adding 1 to the exponent will be negative 2 plus 1 will be negative 1, divide by the new exponent, then plus c. So you can write the final answer as negative 1 over 4x minus 3 plus c. Or you can just leave your answer this way if you are not so comfortable with moving back and forth with the negative exponent. Okay, so another question, we've passed the 5 minutes mark. Another question, integral of square root of 7x minus 4 dx. Okay, so this can be written as integral of 7x minus 4 all raised to the power 1 over 2 dx. So to integrate this one, we need to integrate the entire thing. So integrating the entire thing will be 7x minus 4. You add 1 to the exponent. 1 plus 1 over 2 is going to be 3 over 2. Divide by the new exponent. Then multiply by 1 over the differential of what is inside. The differential of what is inside is 7. So this simplifies to 7. 3 over 2 times 7 will be 21 over 2. So because of this being 20, okay, let me just write it then. 7x minus 4 raised to the power 3 over 2 divided by 21 over 2. Now, because of the division sign, we can case this one and change it to multiplication. So this becomes 2 over 21 instead. So let me just delete the 21 over 2. Okay. Then the final answer will be written as 2 over 21, 7x minus 4 raised to the power 3 over 2 plus a constant of integration. So we've done a lot of examples on this, and I think this concept should be fairly easy to understand. So it's just moving on from the previous concept that says that if you've got any integration of the form x raised to the power n, this gives you x raised to the power n plus 1 over n plus 1 plus a constant of integration c, where n is not equal to negative 1. And it's kind of goes on to tell you that if you've got ax plus b raised to the power n dx, then this gives you ax plus b. We add 1 to the exponent, divide by the new exponent. But with this one, you multiply by 1 over the differential of what is inside. In this case, the differential of what is inside is a, and you add your constant of integration c. So that is the concept for today. We'll meet some other time. In the next video, we're going to look at maybe the exponential functions and how to integrate them. Bye bye for now.